Welcome to Next Minds Academy daily lessons. Remember to subscribe to our channel, Mr. Academia, to enjoy all our lessons and study with us. We are going to look at sets and the notations and the language that we use in sets. So today you should be able to describe all set symbols that you basically use in sets. You should also use the set symbols appropriately and the set language, and also draw Venn diagrams. So if we look at a set, it is a collection of objects, ideas, or any other things. So sets are basically named by describing the objects or ideas or whatever you're dealing with, and also by listing the members. So examples of sets, for example, the set of people in a given room, set of exercise books in Form 1, or we can have a set of members which are 1, 2, 3, 4, 5, and 6, or we can have a set of members which have these letters here. So all these are what we call sets. So if you look at some of the symbols that we use in sets, so the symbols are given here. So they are what we call curly brackets here. These curly brackets, these ones here. So these curly brackets, they mean a set of. So for example, if I have the curly brackets and then inside I have people in this room, so this one can be read as a set of people in this room. It can be read as a set of people in this room. So members or elements of the set are the ones which are inside the curly brackets here. So for example, here the members A, E, I, O are the members of this set. Of course, the members of the set are vowels, which are A, E, I, O, and U. Then the symbols used, the symbol used is this one here. This symbol means is a member of. So for example, you can ask, is R a member of this set? So to respond to this, you just say R is not a member because R is not a vowel. So we write this as R is not a member of. So we use this cross here. The cross to the sign is a member of. We cross it out and read this R is not a member of the set of vowels. We also use capital letters when writing sets. So for example, the set A here, you can see capital A here, which we read as the set A. So using capital letters, it enables us to write statements about sets in a brief way. So for example, if we are to read this, A is a member of set A, R is not a member of set A. So the capital letters they are basically used to represent a set, and that is how we do read them. If you look at the number of members, we use this symbol N is what we use, like here. If the set is for vowels, as we see here, it has 5 members. So when writing or showing that A has 5 members, we write the number of members in set A equals to 5. So the number of members of set A equals to 5 is written in this way here. So when a set is empty, we represent that by using this symbol here. We write curly brackets which have no element inside, or we just use this symbol here to represent an empty set. So these are the two symbols that we use to represent an empty set. So if you write your empty set like this, if you combine the two and write your empty set like this one is a wrong way of representation of an empty set because it shows that you've added an element in the curly bracket. So this is not a correct representation of an empty set. Moving on, if you have to look at subsets, so if we have two sets, A and B, and A is a subset of B, A is said to be a subset of B if every element in A is also an element of B. So this is written as A is a subset of B. So you can see the symbol that we use for subset. So for example, if one set A, it has these ones and set B has these members here. So you can see that all the members of this set are also in this set. So this implies that this set is a subset of this one, which is written clearly like this, as you can see here. Okay, so if you are to move on, for example, since any integer is, so clearly you can see that that is how. So if it is not a subset, then you can see the cross that we use when a set is not a subset of the other. So the union of sets, so the union of sets is a single set which consists of all members of both sets. So when you combine all the members of the two sets, what you get is what we call a union of sets. Even if there are three sets, if you combine all the members of the three sets, what you get is the union of the sets. So it is written like this. So this is the symbol for A union B, which represents all members of set A and set B, and it can be represented by the shaded region. So this shaded region is the region that contains all members in set A and set B. So meaning that if you're to write members in A union B would have R, would have S, would have T, would have P, would have Q, and would also have U. So the union of A and B basically contains members of set A only. It contains members of A intersection B, and it also contains members of set B only. Then the intersection of sets. So the intersection, it consists of members which are found in both sets. So for example, if we still use set A and B, so you can see that P is in set A, P is in set B, Q is in set A, and Q is in set B. So meaning that the intersection of set A and B consists of elements P and Q, which are both in set A and set B. So in a Venn diagram, it is this part here, the intersection of set A and B, which has members P and Q. So if you have to count the number of members in the intersection of A and B, it is P and Q, but the number is 2. So the universal set, for it is a set containing all members in a described set. So for example, the universal set can consist of counting numbers less than 10. So if A is this and set B is this, so all these ones here, they are all counting numbers less than 10. So meaning that both A and B are subsets of the universal set, or they are part of the universal sets that consists of counting numbers less than 10. If we look at complement, the term complement of a set, it is a set which contains members that are not in the universal set, that actually members are in the universal set but are not found in the set under consideration. So for example, if you are looking for the complement of A, those are members which are not in set A, but they can be in set B and in the other remaining part of the universal set. So A complement are members which are not in set A, and B complement are members which are not in set B, using the same sets that we looked at before in the previous slide. So thank you for attending with us. Continue subscribing to our channel to enjoy all our live lessons.